All right, so these are going to be the notes for day 3, set builder, number line graphs, absolute value, and distance. So starting with these notes here, this is stuff you may have seen in Algebra 2, and we're reviewing it with you all so you can just kind of get a good sense of what you should be doing here. All right, so first sentence says, in set builder notation, the element of the set are described but not listed. So we have a statement here, and mathematically how you read it is like this. So the set of all x, and this line means such that x is a counting number less than 6, okay? So that is how we read this expression, or this notation here, okay? Now you can write this as a list of numbers to represent that, and it's going to be the same set written using the roster method. So if you think about it, counting numbers start at 1, they go to 2, 3, 4, 5, and 6. But this is counting numbers less than 6, so we don't include 6, we end at 5. So 1, 2, 3, 4, 5. And notice this is a set of numbers, so we have the braces to represent a set, and each number inside of here would be considered an element. Now, the set builder is something that was previously learned in Algebra 2. And now let's talk about interval notation. This is also something you may have seen in Algebra 2 as well, and possibly in Algebra 1. So here it says, some sets of real numbers can be represented using interval notation. Suppose that A and B are two real numbers such that A is less than B. So what this means is that we have two numbers. A will always be the smaller number, and B will always be the greatest number. Okay, so it's like a book. You read a graph, a line from left to right. So the first one, open interval. So A comma B. So the first thing you want to notice is that we do have parentheses around A and B. So remember, A is the smaller number, B is the greater number. Parentheses means that it is open interval. This represents the set of real numbers between but not including A and B. So parentheses A comma B close parentheses is the equivalent to the set builder notation that X such that A is less than X, which is less than B. Okay, so X is greater than A and X is less than B. Now, graphically, this is one way you can look at it. Notice the parentheses means not included. Another way that you might be used to seeing this is open circle. Going all the way over here, open circle. So when we show that something is not included, we use parentheses, okay? So this is the smaller number right here, A. Notice it comes first. And the larger number, or the greater number, is B, and that comes second. Since we have open circles, we use parentheses to represent that. Now, the parentheses in the graph and in an interval notation indicate that A and B, the endpoints, are excluded from the interval. So A is the one endpoint and B is the other endpoint. All right, moving on to the next one. Closed interval. So if open interval meant open circles, closed interval means you're going to have closed circles. And it's closed circles on both points. We're going to talk about that in a moment, why that is. Okay, so first off, it says the closed interval bracket A comma B bracket represents the set of real numbers between and including, so keyword here, including A and B. So bracket A comma B bracket. This set builder notation is X such that A is less than or equal to X, which is less than or equal to B. And hopefully this notation is a reminder for your inequality. Since it has the equal bar, that's why these circles are going to be filled in and closed. And then you can read this. It says X is greater than or equal to A, and X is less than or equal to B. So brackets, in terms of the notation you write, that means that the endpoint is included. So the square brackets in the graph and in the interval notation, so the bracket right here and the closed circle, indicate that A and B, the endpoints, are included, okay? So that means that these are closed circles, they're included in your solution for that interval. Okay, next we have something called the infinite interval, and hopefully you can see that. It says parentheses A comma infinity, close parentheses, and we all know that this infinity is probably where it's infinite. It represents the set of real numbers that are greater than A. So once again, if you're starting to catch on here, we know that A is the least and B is the greatest. So therefore, hopefully you're making the connection that your smallest number comes first and your greater number comes second. So infinity, we don't actually have a value for that, but we do know that it's going to be bigger than A no matter what. So here, parentheses A comma infinity, parentheses, X such that X is greater than A. So the infinity symbol does not represent a real number. It indicates that the interval extends indefinitely to the right. Now, one thing I want to point out, if you notice, we have a parentheses here, and because the definition tells us the symbol does not represent a real number, so we don't actually know the value of infinity, so we use a parentheses to show that it's not included because it never actually ends. And so you can see right here, this parentheses represents an open circle, and that's where a value is, and it goes to infinity. So if you wanted to see it, this would be a, and this would be infinity. The parentheses indicates that a is excluded from the interval. All right, on to the next here. Okay, so the infinite interval again, and this time we're coming from negative infinity to b. But this time, pay attention to the letter b. The b actually has a bracket, okay? So that's important because hopefully by now you picked up that brackets mean closed circle and that it's included. Once again, positive infinity had a parentheses because it was not included. Negative infinity also has a parentheses because that will not be included either. So this interval represents the set of real numbers that are less than or equal to b. So you can read this again, parentheses, negative infinity, comma, b bracket, equals x such that x is less than or equal to b. The negative infinity symbol indicates that the interval extends indefinitely to the left. So right here we can see this arrow goes to the left forever. The square bracket indicates that b is included in the interval. So if we wanted to represent this with open and closed circles, we know that this right here, this arrowhead goes towards negative infinity, and this bracket actually represents an endpoint that is a closed circle. So this heads towards negative infinity, and that is b with the closed circle. And then table P2 on page 11 lists 9 possible types of intervals used to describe the subsets of real numbers. Okay, so let's kind of take a look at these examples here. So example 3, it says, express each interval in set builder notation and graph, okay? So what I'm going to do is I'm going to actually graph them first. So I'll graph these in purple. So I like the graphs because they're pretty easy. So we're just draw a number line. And now, we're only going to put the two numbers, -1 and 4. Notice my graph is least to greatest. Now, this -1 has a parentheses, which we know means open circle. And this 4 also has a parentheses, which also means open circle. And what we'll do from here is we're going to connect them. And it's a closed interval, or it's an open interval, but they're connected. So let me actually change the color so you can actually see it better. And we can see that it is connected right there. There it is. Okay. Now, if I'm going to do set builder notation, we start with the braces, x such that, and we start with the smallest number, -1, and that's an open circle, so we can see that -1 is less than, right? So less than x, and x is still less than the greatest number, which is going to be 4. So that's always going to be your interval. Let's make this a little bit bigger here. There we go. So -1 is less than x, which is less than 4. Remember, no equal bars because these are open circles. All right, let's try the next one. So again, we'll draw our number line. We have a bracket on 2.5, so that's going to be a closed circle. And we have a bracket on, or a bracket on 4, and that's also going to be a closed circle. So let me go ahead and use my blue pen to fill this in so you can see it. And we're going to connect those. So again, here my smallest number is going to be 2.5 and my larger number is going to be 4. So braces, x such that, so we start at 2.5 is less than, but this time we're going to put equal because that's a closed circle, x, which is less than or equal to, because that's a closed circle, and it's less than or equal to 4. And there is my inequality notation, there's my graph, and there's my interval. All right, we're down to this last example here. So again, draw a number line. So least is -4, and that's going to be an open circle. And now infinity, we can write infinity if we wanted to, but we have to understand that infinity is an arrowhead that goes on forever and ever. Okay, so let's go ahead and fill this in. So open circle here at -4. Arrowhead going towards positive infinity, and let's connect our points. So this one here, I'm going to show you 2 ways to write it, and really it's your choice how you do write it. The first way you can write it, and people like to do this because it's easier to see, they'll start with -4, and they can see that -4 is less than, but not equal to, because it's an open circle. And here we don't put infinity, we're actually going to put the variable that it represents, and we're representing x. Now that way, it is acceptable because it is true, -4 is less than x. The way I personally like to write it, and you may see more often, is going to be braces, x such that. And we're just going to turn it around. We're going to start with the x first, and we notice that it's opening towards the x, the little opening there, and then -4. And this just shows the exact same equivalent statement, x such that x is greater than -4, meaning you're going towards positive infinity. All right, let's take a look at the next one. Absolute value. So the absolute value of a real number denoted by absolute bar A, absolute bar, is the distance from 0 to A on the number line. This distance is always taken to be non-negative. So an example is the absolute value of -3 is equal to 3, because -3 is 3 units away from 0. That's why it looks like it's positive 3. And just like 5, the absolute value of 5 is 5, because 5 is 5 units from 0. Okay. Now, right here, it says to rewrite each expression without absolute bars. So for this one here, let's go ahead and take a look at it. Give me 1 second here. All right. So letter A. Give me 1 sec, sorry. Okay, so right here we have the square root of the absolute value of the square root of 3 minus 1. What's going on here? Why is this missing? Okay, is positive the absolute value of A. Sorry, so let's start again. Sorry about that. Okay. So the square root of 3 is approximately 1.7, okay? So when you're looking at this, we know the absolute value is supposed to yield a positive number because it's the distance away from 0, okay? So let me kind of walk you through this. So the square root of 3 is approximately like 1.7, okay? And if I took 1.7 and I took away, sorry, if I took 1.7 and minus 1 from it, I would get 0.7. And as you can tell, that is actually going to be a positive number. So in this case, your answer, we're just going to drop the absolute bars and get the square root of 3 minus 1 is our answer. Okay, and the reasoning why, once again, the square root of 3 is 1.7. If I took away 1 from it, I would get 0.7, and that is positive. So therefore, I can just drop the absolute bars, and the square root of 3 minus 1 is going to be my answer. All right, let's take a look at letter B. So we have 2 minus pi. And we're going to take the same concept, right? So we understand that pi is approximately 3.14. All right, so this time it says the number inside the absolute value bars, 2 minus pi, is going to be negative, right? Because if we took 2 and we subtracted 3.14 approximately, we would get something along the lines of negative 1.14. So notice that's negative. And when you're taking the absolute value, it has to be positive. All right, so the absolute value of x when x is less than 0 is actually going to be negative x. So let me kind of show you what this means we're going to do. So we're going to take the 2 minus pi, and we're going to take the negative part because the absolute value is positive and negative distances away from 0. So we can take negative. We're going to drop the absolute bars and change it to 2 minus pi. Okay, and here's the reason why I'm doing this. You'll see in a sec. Because right now, we know that 2 minus pi is going to give me a negative number. But when I place the negative in front and I distribute it, I get negative 2. And a negative times a negative is positive. So if you were to add these two together, then you would get a positive number, right? And let me just write it one more way because we like to have the pi first. So pi minus 2 is going to be my answer. Because if you think about it here, if I took 3.14 and subtracted 2, I would get positive 1.14. And that's positive. So that's actually what I did need there, okay? And now for this last one here, It said the absolute value of x divided by x if x is less than 0. Okay, so once again, I'm going to bring that concept up. Like, so we have two distances, and that's why this one worked, because 2 minus pi, one on the right side is the same distance as the one on the left side of the number 0. Over here, we have x. X is so many units away from 0, just like x is negative so many units away from 0 as well. So the absolute value of x divided by x if x is going to be less than 0. Okay, so here we can take this. So since it's less than 0, the absolute value of this x, so if it's less than 0, the absolute value of this one, they're asking us to use negative x. Sorry. And we're going to divide that by x, right? Because it says if x is less than 0, and we're only focused on the absolute value one. The x here does not change. So if it's less than 0, they're asking us for the negative part. So that's why we write negative x. And hopefully you can see that negative x divided by x is going to be negative 1. All right, so that one's just a tad bit different than the previous ones. And we can talk about this more on Friday. All right, and last but not least, we have this right here, distance between points on a real number line. So for this here, it says the absolute value is used to find the distance between 2 points on a real number line. If a and b are any real numbers, the distance between a and b is the absolute value of their difference. So this keyword is difference. Difference means to subtract, right? So for example, the distance between 4 and 10 is 6. Using the absolute value, we find this distance in one of two ways. So let's take a look. So 4 and 10, so we can do 10 minus 4, which is 6, and notice we're taking the absolute value. The absolute value of 6 is 6. If we wrote it the other way, so we do the absolute value of 4 minus 10, that's negative 6, right? But then we take the absolute value of negative 6 and we get 6. So notice both answers, when you do it, are going to yield the number 6. Sorry. Okay, so notice we obtain the same distance regardless of the order in which we subtract when we use the absolute value. All right, so the distance between 2 points on the real number line, and it says if a and b are any 2 points on a real number line, then the distance between a and b is given by the absolute value of a minus b or the absolute value of b minus a. So it's really up to you. It's not going to change it, okay? So for example 3, find the distance between negative 5 and 3 on the real number line. So it doesn't really matter. I'll pick this one to be a and this one to be b. And you don't have to do it both ways. I'm just going to show you what it looks like using both ways. So let's say I decided to use the absolute value of a, which is negative 5, minus b, which is 3. And negative 5 minus 3 is negative 8, and the absolute value of negative 8 is 8. Okay? Now if you wanted to do it the other way, b minus a, then b is 3, so the absolute value of 3 minus a, which is negative 5. So I'll put this in parentheses so you see what happens. A negative times a negative is positive, so the absolute value of 3 plus 5, which is the absolute value of 8. And the absolute value of 8 is 8. Okay, so you notice both answers yield, or both methods yield the same answer. All right, example 4, I'm just going to show you one of them. I just like to stick with whatever's there, so the absolute value of a minus b. So we'll call this a, we'll call this b. The absolute value of a is negative 4 minus b, which is 5. Negative 4 minus 5 is negative 9. And the absolute value of negative 9 is going to be 9. All right, and then from here, you can see your homework, page 17, numbers 59 through 72, 85 through 94, 101 through 108, and 109 through 116 all. And that's going to be your homework for tonight. And if you do have questions on Friday, we can definitely discuss those. Have a good one.